Hi, my name is Nick, I'm a maths tutor, and today we're going to go through Edexcel GCSE Maths November 2021 Paper 1H. Let's give it a go. Work out 3.67 times 4.2. So this is long multiplication here. So in the first row we multiply by 2, so we do 2 times 7, which is 14, 2 times 6 is 12, plus 1 is 13, and then 2 times 3 is 6, plus 1 is 7, so you get 734 there. Then we're going to do 40 times 367, so we put a 0 on the right hand side, and then we have 4 times 7, which is 28, 4 times 6, which is 24, plus 2 is 26, and then 4 times 3 is 12, plus 2 is 14. So we do 4 plus 0, which is 4, 3 plus 8, which is 11, 7 plus 6, which is 13, plus the one we carried over is 14, 4 plus 1 is 5, and then 1 plus nothing is 1. So then we have 15,414, but remember we've got 3 decimals to fill in, so we go 3 from the right, and we have 15.414 as our answer. Moving on, we need to work out 59.84 divided by 1.6. So you can think of this as 598.4 divided by 16 when we multiply the numerator and the denominator by 10. We then do long division for this. We have 598.4 divided by 16. And then we do 16 into 5 is 0, so then we do 16 into 59, and then you do a bit of estimation. I did 16 times 4, and that gave me 64, so that's too big. 16 times 3 then is 48, so I'm going to use that. So we have 3, and then we do 59 minus 48, and we get 11. We then drag down the 8, so we're looking at 118, and we can see that if we do 16 times 8, we get 128, which is too big. So we do 16 times 7, and we get 112. 118 minus 112 is 6, and then we drag down the 4 and we have 64, and then remember from earlier that's just 16 times 4, so we have 37.4 as our answer. Complete the Venn diagram for this information. So what we're going to look at is A and B and which numbers they have in common. So we can see they have 6 and 18, so we put them in the middle, and then we can see A has 12 left over, so we put that on the A side, and then we have 2 and 14, which we put on the B side. We're then left with all the even numbers less than 19 that aren't within A or B, so we have 4, 8, 10 and 16, and then we can move on. Work out 4 and 1/5 minus 2 and 2/3. Give your answer as a mixed number. So the first thing I'm going to do is convert these mixed fractions into improper fractions. So 4 and 1/5 is 21/5, and 2 and 2/3 is 8/3. So we have 21/5 minus 8/3. I'm then going to find the lowest common denominator and then go from there. So we have 15, so we do 21 times 3 and 5 times 3 to get 63 over 15, and then we do 8 times 5 and 3 times 5 to get 40 over 15. So we now have 63 fifteenths minus 40 fifteenths. That gives us 23 fifteenths, and then remember we need it as a mixed number, so we do 1 and 8 fifteenths as our final answer. At the end of 2017, the value of Tamara's house was £220,000. The value of Raheem's house was £160,000. At the end of 2019, the value of Tamara's house had decreased by 20%. The value of Raheem's house had increased by 30%. At the end of 2019, whose house had the greater value? You must show how you get your answer. So we can write this algebraically, and we think of 220,000 times 0.8 as the value of Tamara's property in 2019, or T 2019 here. 160,000 times 1.3 is going to represent our 30% increase for Raheem's house in 2019, and then we can move on. So if we have Tamara's house in 2019 being 220,000 times 0.8, we can think of this as 22,000 times 8. So we do 22,000 times 8 and we get 176,000. Then we need to find Raheem's house in 2019, so you can think of 160,000 times 1.3 as 16,000 times 13. So then do long multiplication for this, and we end up with 280,000, because we do 3 times 16,000 and we get 48,000. We then do 10 times 16,000, which is 160,000, and then we add them together and then we get 208,000. So at the end of 2019, Raheem's house has a greater value of £280,000 than Tamara's house, which is £176,000. Rosie, Matilda and Ibrahim collect stickers. The number of stickers Rosie has to the number of stickers Matilda has to the number of stickers Ibrahim has is 4 to 7 to 15. Ibrahim has 24 more stickers than Matilda. Ibrahim has more stickers than Rosie. How many more? So we know the ratio of stickers between Rosie, Matilda and Ibrahim is 4 to 7 to 15, which I've written as R to M to I. We also know that Ibrahim has 24 more stickers than Matilda, so we can write that as I is equal to M plus 24. Then we know Ibrahim has more stickers than Rosie, and we need to find how many more, so we can say I minus R is X, where X is a value we're trying to find. If we take our ratio and look at 15 minus 7, we can look at the difference between Ibrahim and Matilda in that ratio, which is 8. We know that the difference between Ibrahim's stickers and Matilda's stickers is 24, so we need to multiply up this ratio by 3, and we know this because we do 24 divided by 8, which is 3. So to find the actual number of stickers, we multiply the ratio by 3. So we do 4 times 3, 7 times 3, and 15 times 3, and we end up with our new ratio of 12 to 21 to 45. We then do 45 minus 12, because that's Ibrahim's stickers minus Rosie's, and that gives us 33, which is our final answer. The diagram shows a prism. The cross-section of the prism is a right-angled triangle. The base of the triangle has length 5 centimeters. The prism has length 25 centimeters. The prism has volume 750 centimeters cubed. Work out the height of the prism. So we know that the area of the triangle is going to be a half base times height. So we do h times 5 divided by 2 to find the area. We then multiply this by 25, which is the length, to get the volume, and we know that's 750 centimeters cubed, so we can now find h using this equation. We have h times 5 times 25 is 1500, because we've multiplied both sides by 2, and then we can divide both sides by 5, and we get h times 25 is equal to 300, and then divide both sides by 25, and we get h is equal to 300 over 25. We multiply both sides by 4, we get 1200 over 100, and then we can just draw off those zeros on the numerator, so we have 12 centimeters as our final answer. The diagram shows a cube with edges of length x centimeters and a sphere of radius 3 centimeters. The surface area of the cube is equal to the surface area of the sphere. Show that x is equal to the square root of k times pi, where k is an integer. So we know the surface area of the cube is going to be 6 faces times each area of each square. So then we're going to have 6 times x, which is 6x squared. The surface area of the sphere, using the equation we've been given of 4 pi r squared, is going to be 4 pi 3 squared. This gives us 4 times 9 times pi, which is 36 pi. We know that the surface area of the cube is equal to the surface area of the sphere, because we're told that in the question, so that means that 6x squared is going to be 36 pi. We divide both sides by 6, and we get x squared is equal to 6 pi, and therefore x is going to be the square root of 6 pi, and that is our final answer. Solve x squared equals 5x plus 24. So we rearrange the equation and we get x squared minus 5x plus 24 equals 0. We then need to factorise this equation, so we can look at the factors of 24 and figure out which difference would allow us to get the equation that we're looking for. So we're going to do x minus 8 and x plus 3 within our brackets to factorise the equation, which therefore means the solution is x equals 8 and minus 3. Write down the value of 7 to the power of 0. This is just 1 because anything to the power of 0 is 1. Find the value of 3 times 3 to the power of 6 times 3 to the power of minus 6. So 3 is the same as 3 to the power of 1, and then we can look at adding all of the indices. So we do 1 plus 6 minus 6, and that leaves us with 1, so therefore 3 is our answer. Find the value of 2 to the power of minus 4. So this is the same as 1 over 2 to the 4, because remember a negative means it becomes a denominator. So then we have 1 over 2 squared to the power of 2, because you can think of that as 2 to the power of 4. Therefore we have 4 squared, which is 16, so the answer is 1/16. Find the value of 27 to the power of a third. So this is the same as the cubed root of 27, which is just 3, so 3 is our answer. The diagram shows a shape made from 6 identical squares. The total area of the shape is 5,406 centimeters squared. Find an estimate for the length of one side of each square. Give your answer correct to the nearest whole number. So 6x squared is going to be the surface area of all of the squares combined, and that is 5,406 centimeters squared as we're told in the question. We divide both sides by 6 and we get 901 centimeters squared is equal to x squared. Therefore x squared is roughly equal to 900 because we need to find an estimate, and therefore x is going to be the square root of 900, which is 30, so 30 centimeters is our estimate for the answer. Is your answer to part A an underestimate or an overestimate? You must give a reason for your answer. I said it was an underestimate as my approximation rounded down, meaning the actual answer to part A would be larger. The diagram shows two rectangles A and B. All measurements are in centimetres. The area of rectangle A is equal to the area of rectangle B. Find an expression for y in terms of w. So the area of A is going to be 6 times 2w plus y. This expands to 12w plus 6y. The area of B is going to be 7w times 3y plus 6, and this expands to 21wy plus 42w. The area of A is equal to the area of B, so therefore 12w plus 6y is equal to 21wy plus 42w. We rearrange this and we get 6y minus 21wy is equal to 42w minus 12w. So here I've subtracted 12w from both sides and 21wy from both sides. Now that I've got all the y's on one side, I can factorise and I get y times 6 minus 21w is equal to 30w because I've simplified the right hand side there. Then we get y is equal to 30w over 6 minus 21w, so I've divided 6 minus 21w from both sides, and that gives us 10w over 2 minus 7w, and that is our final answer. The cumulative frequency table gives information about the height in centimetres of 40 plants. On the grid, draw a cumulative frequency graph for this information. So we need to plot all of our points, so we're going to have 5, 4, 10, 11, 15, 24, 20, 34, 25, 38 and 30, 40, because I've looked at all of the grouped frequencies within the left hand side of our table and looked at the largest number that it has. So then we plot all of these points and then we just draw straight lines between all of the points and we have our answer. Then we need to use the graph to find an estimate for the median height of the plants. So 40 divided by 2, which is 20, to find the median height. So we do 20 and then we read across and we find that the height would be 13.5 for the median, and that is our answer. Ted is trying to change 0.43 recurring to a fraction. Here is the start of his method. Evaluate Ted's method so far. So Ted should use 100x instead of 10x to ensure the recurring values following the decimal cancel out. So for example, 43.43 recurring minus 0.43 recurring, instead of what he's done here where he has 4.34 recurring, and as you can see the 3,4 and the 4,3 don't match up nicely. Here is a shape with all its measurements in centimetres. The area of the shape is a centimetres squared. Show that a is equal to 2x squared plus 24x plus 46. So we can split up this shape and we have 4x plus 4 as the top area, because we do x plus 1 times 4. And then for the bottom area, we need to do x plus 11 minus 4, and that gives us x plus 7 for the right hand side. And then 2x plus 6 is our base, so we do 2x plus 6 times x plus 7 for that area. So we can say the area of A is going to be 4x plus 4 plus 2x plus 6 times x plus 7. This expands to 4x plus 4 plus 2x squared plus 6x plus 14x plus 42. And then we can solve this for 4x plus 4 plus 2x squared plus 20x plus 42. And then this simplifies to 2x squared plus 24x plus 46. Show that 4x plus 3 over 2x plus 3/5 can be written in the form ax plus b over cx, where a, b and c are integers. So 4x plus 3 over 2x plus 3/5, we need to find the lowest common denominator, which is 10x. So we have 20x plus 15 over 10x, because we multiplied by 5 for the left-hand fraction, and then we multiply by 2x to get 6x over 10x. We then add these together and we get 26x plus 15 over 10x as our answer. There are only 3 red counters and 5 yellow counters in a bag. Jude takes at random 3 counters from the bag. Work out the probability that he takes exactly 1 red counter. So we know there's 3 red counters and 5 yellow counters, so therefore the different variations of taking 3 counters from the bag are 3 reds, 2 reds and 1 yellow, 1 red and 2 yellows, and 3 yellows. So we need to find out the probability that he takes exactly 1 red counter, so we need to look at 1 red and 2 yellows. There's 3 ways you can do this: red, yellow, 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 red, yellow, or yellow, yellow, red. So this is the order in which you take them out. When we look at these, we can see that if we go red, yellow, yellow, we have 3/8 probability of taking a red, then 5/7 probability of getting a yellow, because they've removed 1 counter and there's still 5 yellows left, and then 4/6 as the final yellow. Then for the rest, we have 5/8 times 3/7 times 4/6, and 5/8 times 4/7 times 3/6. So when we put all of these together, we can see we actually have the same fraction 3 times with the numbers just mixed up. So we can look at this as 3 times 3 times 5 times 4 over 8 times 7 times 6. I then simplified this, so the 3 and the 6 become 1 and 2, and the 4 and the 8 cancel to 1 and 2. So this simplifies to 3 times 1 times 5 times 1 over 2 times 7 times 2, and this becomes 3 times 5 28, which is then 15 28, which is our final answer. On the grid, show by shading the region that satisfies all of these inequalities. Label the region R. So we've got 2y plus 4 is less than x. We can rearrange this to 2y is less than x minus 4, and that is the same as y is less than a half x minus 2. Then we've got x is less than 3, and we have y is less than 6 minus 3x, but we rearrange this to minus 3x plus 6, so we can write it on the graph. So we start off with y is less than minus 3x plus 6, and we can see that to plot that, we start with 6 as our y-intercept, and then for every 1 that we go across, we go 3 down, so you get the line you can see here, and we draw it dashed because it's less than, and it's not equal to or less than. Then we can draw on x is less than 3, which is just a vertical line from x equals 3, and then we need to draw it dashed again because it's less than and not less than or equal to. And then finally we have y is less than a half x minus 2. So remember the y-intercept is minus 2 and the gradient is a half. So for every 2 we go across, we go 1 up. So therefore we have the line you can see here, again dashed for the same reason. And then we need to shade the region that satisfies all of these. So you can see I've drawn little arrows for each of them. and R is the region you can see here that satisfies all of those inequalities. Here is trapezium ABCD. The area of the trapezium is 66 centimeters squared. The length of AB to the length of CD is 2 to 3. Find the length of AB. So the area of a trapezium is half the sum of the parallel sides times the distance between them. So we have a half times AB plus DC times H, which is 66. We know the ratio of AB to CD is 2 to 3, so therefore CD times 2/3 is equal to AB, and therefore CD is equal to 3/2 of AB. If we look at a triangle on the right hand side, we can see we have the 30 degrees and the length BC, and that could give us H because we use sine to get there. So we have 6 sine 30, which is H, because remember sine uses the opposite and the hypotenuse. So remember sine 30 is a half, and I did that using my table here, and then we can move on. A half times AB plus 3/2 AB, because here I've just swapped DC for 3/2 AB, times 3, because 3 is the value of H, then gives us 3/2 times 5/2 AB, which is then 15/4 AB. Remember this is equal to 66, so we can then rearrange and we get 66 times 4 over 15 is equal to AB, and therefore we can simplify 66 and 15 by dividing by 3, and we get 22 times 4 over 5, which is 88 over 5, and then we do this as a division and we get 17.6 as our answer. Show that 8 plus the square root of 12 over 5 plus the square root of 3 can be written in the form a plus root 3 over b, where a and b are integers. We've got 8 plus root 12 over 5 plus root 3, and we multiply this by 5 minus root 3 over 5 minus root 3, because it cancels the square roots on the bottom of the fraction. So we then end up with 40 minus root 36 plus 5 root 12 minus 8 root 3 over 25 minus 3. This then becomes 40 minus root 9 times root 4, because remember that is root 36, plus 5 times root 4 times root 3, because that's root 12 for the root 4 times root 3, and then we have minus 8 root 3 over 22, because 25 minus 3 is 22. Then we do 40 minus 3 times 2, because remember the root of 9 is 3 and the root of 4 is 2, then plus 5 times 2 root 3, because the square root of 4 is 2, minus 8 root 3 over 22. Then we can simplify this further and we get 40 minus 6 plus 10 root 3 minus 8 root 3 over 22. This becomes 34 plus 2 root 3 over 22, and then this simplifies to 17 plus root 3 over 11 when we divide by 2. The diagram shows the graph of x squared plus y squared equals 30.25. Use the graph to find estimates for the solutions of the simultaneous equations x squared plus y squared equals 30.25, y minus 2x equals 1. So we can rearrange the second equation to y equals 2x plus 1 and then draw this on the graph. Remember the y-intercept is going to be 1 and the gradient is going to be 2, so we draw on the line as you can see here, and then where the points intersect is going to be our solutions. So we have x is 2 and y is 5.2, and we have x is minus 2.8 and y is minus 4.8, and those are solutions. The functions f and g are such that fx is equal to 3x squared plus 1 for x is greater than 0, and gx is equal to 4 over x squared for x is greater than 0. Work out gf of 1. So we can think of gf of 1 as a nested bracket. We have g of f of 1. This becomes g of 3 times 1 squared plus 1, which is then g of 3 plus 1, which is g of 4. G of 4 is the same as 4 over 4 squared, which is 4 over 16, which is 1/4, and then we can move on. The function h is such that h is equal to inverse function of fg. Find h of x. Remember f of g we can write as a nested bracket, so we have f of g of x. Then we have f of 4 over x squared, because we've replaced gx with its equation. So then we substitute that in our equation for f. So we have 3 of 4 over x squared plus 1 is equal to 3 times 16 over x to the power of 4, because we've expanded our brackets, plus 1. This becomes 48 over x to the power of 4 plus 1. And now we've found f of g of x. So we need to find the inverse, so we're going to let x equal 48 over y to the power of 4 plus 1, and rearrange to get y on the left hand side. We then do x minus 1 is equal to 48 over y to the power of 4. This becomes y to the power of 4 equals 48 over x minus 1, when we multiply by y to the 4 and divide by x minus 1. This then gives us y is equal to the fourth root of 48 over x minus 1, which is the inverse function of f of g of x, which is hx. So therefore our answer is hx is equal to the fourth root of 48 over x minus 1. Find the coordinates of the turning point on the curve with the equation y equals 9 plus 18x minus 3x squared. You must show all your working. So here we need to complete the square and then we can find our answer. So we factorise a 3 and we get y equals 3 minus x squared plus 6x plus 3. We then can factorise a minus 1 as well, so we get y equals minus 3 times x squared minus 6x minus 3, and that becomes minus 3 times x minus 3 squared minus 9 minus 3. Because remember, when we do the x minus 3 squared, we're going to end up with a plus 9, so we need to subtract that, which is why the minus 9 is there. Then we have y is equal to minus 3 times x minus 3 squared minus 12, because I put the 9 and the 3 together. And then we have minus 3 times x minus 3 squared plus 36. So therefore, when x is 3, y is going to be 36, and therefore our answer is 336. And there we have it. That is Edexcel GCSE Maths Paper 1H from 2021 all done. If you want to see any extra maths videos, make sure to hit the links here. And if you need any extra help with your maths, make sure to hit the link in the description, as I'll be offering online group maths tutoring classes on Mondays and Tuesdays. So make sure to hit the link if you want to sign up. See you in the next one.